Hey guys, welcome back. In this part of Learn Python the Hard Way, we are going to learn more about basic object-oriented analysis and design. And specifically, we are going to learn how to start out defining a program and then defining it based on the different objects, the different classes, and how we would really design and lay out our program. And as always, you'll find the link to the current exercise, the current chapter, in the description below. This is part of the paid section of the book, so you would either need to purchase the book or alternatively, of course, feel free to just follow along with this video. So when we start out with creating a new object-oriented program, there are a couple of different steps that we can typically take in order to start with our idea and then to break it down into individual classes and ultimately in the different objects that we are working with. So in this process that we typically follow, we have 5 different steps that we can follow. We start out with writing or drawing out the problem that we want to solve on a high level. Then we extract key concepts that we basically drew in our solution here in our problem statement and research them. After that, we can create a class hierarchy and create an object map for the concept. So we're basically starting at the very top with our problem or high-level idea, and then we extract out individual concepts, research them, and then create a class hierarchy based on that. After that, we can code the classes and then run a test on them, and finally we repeat those steps with the other key concepts and basically refine the overall code that we write. And it's a top-down approach that we're taking, so starting at a very high level with the problem that we try to solve itself and then breaking it down. And of course, we're going to learn later on how we can combine that with the bottom-up approach, that for example we develop individual solutions of our code and then make that work and build on top of that. And just to practice this, we can take the example of a simple game engine that we want to write. So the first step in our 5-step process would be to write or draw about the problem that we have. So let's say, for example, we want to create a new game that is, for example, called Gothons from Planet Percal number 25, which will be a small space adventure game. And that can be a text-based game that we want to develop. So we start out with the first step. We want to write and draw about the problem. So in this case, we can write a little paragraph for the game, how it should look and feel like. So here, for example, we have the description that aliens have invaded a spaceship and our hero has to go through a maze of rooms, defeating them so he can escape into an escape pod to the planet below. The game will be more like a Zork or adventure type game with text outputs and funny ways to die. So we basically type in the different options that we have, and based on that, different text output will be generated, and then we either win the game or we lose the game. The game will involve an engine that runs a map full of rooms or screens. Each room will print its own description when the player enters it, and then tell the engine what room to run next out of the map. Okay, so that's the initial problem description. That's basically how we want to set up our game. Now at this point, we can then set out and describe each individual scene in our game. So for instance, we're going to have a death scene, of course, when the player loses. So this is displayed basically when the player dies, and for example, it should be something funny and engaging. Then we have a central corridor, which is a starting point that the player starts at, and for example, can start out with a joke, and then after that we build on the different options that the player has, and based on that we can display different other scenes. One of which can be, for example, the laser weapon armory. So this is where the hero gets a neutron bomb to blow up the ship before getting to the escape pod. Then we have the bridge of the ship, which is another battle scene. And then we have the escape pod, which is basically where the hero escapes, but only after guessing the right escape pod. So that would basically be when the player actually wins the game. So these are the different scenes that we want to work with. And at this point, we could just physically draw that out and, for example, draw out a map on a piece of paper, for example, just to have something visual to build on top of. We can also then, as we do that, write a more elaborate description for each room, for instance, and we can really explore our solutions that we want to work with in our game. Now, once we have done that, once we have that basic idea, we can then continue with the second step of our 5-step process and extract key concepts and then research them. So at this point, we have, based on our description, enough information to extract some of the nouns in our problem description and then analyze their class hierarchy. So first of all, we can start out and create a list of all the nouns that we have. So if we go back to our description, for example, we have a noun like aliens here, which is the first one. We have spaceship, hero, and we can basically go through the list that we, or the description that we created, and extract those nouns here. And they will become important later on when we then actually start working with our class hierarchy. So here we can basically see a list of the different nouns, so alien, player, ship, maze, room, scene, and so on and so forth, which again we extracted from the description that we created before. We can then also go through the list of verbs optionally and see if there's anything suitable for a good function name, because the nouns that we are working with, they will end up being our classes, and the verbs that describe something that we want to do, those may end up being functions. So for example, if we go back up here just one more time, we could, for example, have a verb like invaded, for example, or for the hero here, he has to go through the different steps, so that could maybe be a function that we want to incorporate that, so that a player can actually go to different places. So it can be really helpful to create not only a list of the nouns, but also of the different verbs that we want to work with. All right, so once we have done that, we come to the next step, so this third step in our 5-step process. So here we create a class hierarchy and an object map for the concepts that we just extracted in the previous step. So once we have our list of nouns, we can turn that in a class hierarchy by asking what is similar to other things, or what is basically just another word for another thing. So as we look through our list of different words here, we can, for example, say that a room is maybe part of a scene, and a maze is probably also just a scene that we want to work with. And so we can basically create connections there between the different nouns that we identified. And that can also be a hint when we now switch over to creating our classes, what the different dependencies or hierarchies should be between different classes that we create. So here, for example, we see that room and scene are basically the same thing. And we could also take a look at, for example, central corridor, and that would also basically just be a scene. And then we can continue and take a look at all of the different nouns and see if they are somewhat related to other nouns that we have written down. And after we've done that, after we went through the list here and basically identified any kind of relationships between those different nouns, we can now use that as that output that we generated basically for our class hierarchy. And initially we can just write this down on a piece of paper, for example, or maybe even easier, just type it into a text editor. So here, for example, we have, again, nouns like map, engine, and scene, but now we identified that a number of the other nouns, for example, death, central corridor, or for example, the bridge, that these are all related and are also just basically different scenes that we want to work with. So therefore we can take the scene here, and below that we can have the different specific scenes. And we already can identify that probably death, central corridor, and the other nouns here should be subclasses of the scene class, because they will probably share some behavior. So after we've done that with our nouns, we can then go through those nouns again, so this class hierarchy basically that we created, and figure out what actions are needed on each thing. based on the verbs in the description. So if we created the verb list, we can directly take a look at that and then basically identify which verbs would fit with each noun that we identified. Now, for example, from the description that we wrote before or that we saw before, we have, for example, a verb called run, to run the engine, get to the next scene, or get to the opening scene, or enter a scene, and we can then add those basically to the different hierarchies to the classes that we identified. So here when we take a look again at, for example, map, we identified the appropriate verbs here are, for example, next scene and opening scene. For engine, it would be play, and here for scene, it would be enter. So if we are entering one of the different scenes. And of course, these verbs that we identify, those will end up being methods most likely in our different classes that we then are going to define. And as we can see, we follow a clear process here, and we start really out with a very simple way of just defining the solution, then identifying the nouns and verbs, creating a list of those nouns and setting them in relation to each other, and then adding the different verbs to that. Now, once we have basically this list here with the different nouns, their hierarchies, and the verbs that correspond to that, we can now basically take this list here, and we could just basically copy it, and that's the advantage of setting it up in a text editor. Then of course we already have it handy, and we can directly copy it over, for example, to a new code file, to a new Python file that we are working with. And now we basically transition over to the next step, to the fourth step, to code up the classes and a test to run them. So now what we do is we open our text editor by, for example, going ahead here, and I'm using Visual Studio Code, so I'm typing out code and then followed by the name. So I already created a file here called outline op.py, which is basically a Python file. You can create that yourself, of course, and you can create an empty file. And the first step that we would typically do is we would take the text file that we created and we can just copy and paste it in. And let's for right now just comment that out so we don't get an error. And now we have our list of nouns and verbs and can translate those into classes. And that's basically what I already did here. So we take, for example, scene, and then we just define a class for it. So here class scene. In this case here, we are using the Python 2 notation just because that's what the book does. Technically speaking, you don't have to enter object in here. This would be perfectly fine and would be more idiomatic actually for Python 3, but having object in here may make it a little bit more clear that we actually are defining here a class which is a main class which does not inherit from another class. Now once we set up the class name here, just by taking a look at the noun here, we see that we have the enter verb that we associated with it, and that of course will end up being a method. So within the class here we define a new enter method. Of course we have to provide self as a parameter, and for now we're just not going to specify the function or the method any further, but we can just enter pass as a placeholder, and this way we basically set up the scene class here with the enter method. We can now continue and, for example, take a look here at the engine noun that we set up. That of course would also be a class that we set up. And then we have the play verb here, which will also be a method that we set up. And we already know that with our engine here, we basically need to initialize that based on the scene map, so we can already enter an init method in here. After that we have death, which, as we know based on our hierarchy that we created here, should be a subclass of the scene class, which we already defined. So we basically just specify class death and then set that up as a subclass of the death class that we, the death class here as a subclass of the scene class, which we already set up here. And we basically just repeat the exact same steps here for all the different nouns. If you just take a look at the map, for example, here, scroll down a little bit. Here in this case, we have the map class, and here we have two methods, next scene and opening scene, which again are just the verbs that we defined in here. So that would be the first step to basically set this up, to define the different classes and the different methods based on the nouns and the verbs that we identified. And here at the very bottom, we basically just set up the game loop itself, so that we define an object, a map, which instantiates a map that we are playing from. We provide an input here, so in this case a central corridor, the starting scene that we want to work with, and then we call on the engine class and provide the object we just created to provide a starting point. And then finally we have a play method here to kick off our game when we actually run our code file here. Now, once we have done that, of course, we need to provide the details for the different methods and basically write out the program itself. And that's the final step in our 5-step process, the repeat and refine process. So here, this is typically an iterative process. We would basically start out and now write out the different functions, the different methods that we defined, provide additional information, test this while we do it, and then provide all the relevant code in there. So this is typically the process that we would follow, but this is a very top-down driven process. We can of course also do the reverse basically and start from the bottom up. So if we follow the top-down process, which we've just seen, the 5-step process, then we start at the most abstract concepts, the very top with the problem description, and work our way down to the actual implementation. In some cases, and that really can depend on the problem we're working on, it can make sense to also go the opposite way, to start basically at the bottom and finish up a piece of the code, test it, and then build on top of that. So in that case, if we are working from a bottom-up approach, we would follow these steps. We would first of all take a small piece of the problem that we identified when we wrote out the problem description, for example, and then we can just write some code and get it to run. And that would probably just be a small, very small subset of the code that we ultimately want to write, but it can be a good starting point. After that, we can refine our code into something more formal with different classes and automated tests. So while in the first step, we just wanted to get it to work in whatever way, with maybe very ugly code, basically, in the second step, we would then refine that, refactor it, make it more pretty, define different classes, different methods, and really give it that object-oriented structure. After that, we can extract the key concept that we have been using and really research them. We can write a description of what's going on, and then we would basically iterate over that, go back and refine the code, basically throw out the entire code or parts of the code, and then starting over, so really refactoring our code. And we would repeat the entire process, moving on from one piece of the problem to the next one, really working it out. So the benefit of this approach can be that we have something working out relatively quickly, but just starting at some point, and we don't have this huge list of code examples that we wrote out that are very high level. The downside, of course, can be that we end up with some really hacky code. We just try to make it work. So typically the top-down approach can be better, but it really depends on the problem itself. So this bottom-up approach can be better once we are more familiar with programming and we are naturally thinking in code about problems. And it can also be very good when we know small pieces of the overall puzzle, but maybe we don't have enough information about the overall concept. But to get started for now, the top-down approach can be better, and when we get more and more familiar, then the bottom-up approach can be preferable. Now, as mentioned before, we so far just set up the very basic structure for our code. In the next step, we can now go through the different classes, through the different methods, and basically write out the code. And ideally, we would go back to our description, read through the description, and then define basically the different functions, for example, adding the print statements within our methods to really print out the code and have the different decision branches added in there. So in terms of the libraries that we are going to use, we can import the sys module here, the random and the text wrap capabilities from the respective modules here, for example, exit, randint, and dedent. And the last one here, dedent, just allows us to more easily have triple quoted strings. So basically descriptions that span multiple lines. And specifically we are using the text wrap module here. And this means that it basically removes white spaces for us automatically and just makes it a little bit easier to work with multi-line code. And now I already wrote out the code here, but what we would basically do is we would start again with our classes that we wrote. So for example, here with the scene class, we have our enter method here, and we would write out the different statements. For example, here the print statements, and then the exit code. We would repeat the same with, of course, the other classes that we wrote. So for example, here the engine class with the play method, and we would write this out. And typically we would do that iteratively, so we wouldn't just write out all the entire code for each of those methods, but start out with a little bit, then test our code, and then make adjustments based on that. And I'm just scrolling down here a little bit. Then we would do the same with the other classes, for example, the desk class here, with which of course is a subclass of the scene class that we wrote before. We have the central corridor class, which is also of course subclassing the scene class. And you can see we have quite a bit of text in here that we add because we have a text-based game that we're basically writing. We can provide we're asking the user for input, and then based on the input provided, we are going to print out different responses, and depending on which choices we make, we may either win the game or ultimately we may lose the game. And of course there can be different steps and then different chapters of our game. And again, we have the laser weapon armory, which is another scene that we are working with. We have the bridge, escape pod, which would be the scene where we ultimately win the game. And then we have the finished class, basically to tell us that we won the game and that we finished it. And of course then next to the scenes we have the map that we want to set up. Here again with a dictionary of the different scenes that we're working with, which have the key here, the name of the scene, and the value would then be the respective function, the respective class that we defined. Alright, and then ultimately here at the bottom, of course, what we already saw before, we can instantiate the starting scene here, the central corridor. We can use our engine to take the object we defined here, the central corridor class, situate it as an object, and we then start and play our game. So if we just take a look at the code itself, actually I already typed it out here. We here have quite a long Python file with our different classes that we defined on a high level before, and then written out the individual methods that we are working with. So as you can see, it's quite long. It's around 250 lines of code. And now to run our code file, we would of course, as always, switch over to our terminal and then type in Python, followed by the Python number, and then of course followed by the name of the Python file that we want to execute. And once we do that, we will basically start our game here. We get the initial scene that is displayed, written out, and then we can perform an action, for example dodge here. And in this case we already died basically, so that was a wrong choice here, but that's basically how we can then play our game. And this is the basic process that we would take in order to define our game, or more generally speaking, how we would take a problem statement that we want to work through, writing it out, our solution that we want to aim for, then identifying the different nouns and verbs, creating basically the hierarchy we want to work with, and associate the nouns that belong together. Then we would also add the verbs in there to the different nouns, which end up being our methods, while the nouns, of course, will be the classes. We will write this out in code on a high level with the classes and the methods without any content yet, and then ultimately we would start one class, one method at a time, and write out the specific code. So that's the top-down approach, and as we become more and more familiar with programming, we may want to transition over to a more bottom-up approach, where some of the class structure and the method definition becomes more intuitive, and we don't have to follow this top-down approach so strictly. And that's basically the approach we would take here. Then of course we can go through the study rules here, and if we wanted to, we could make some changes to our game, for example, adjust it a little bit further, and take a closer look at how the code specifically transitions between the different scenes, and of course basically build on top of that. And finally we have one common student questions. So where can I find stories for my own game, which is of course very specific to the specific problem we are working at here. Of course we can make them up just like we would tell a story to a friend, or we can take some inspiration, for example, from a book or a movie, take that as a basis, as a foundation, and then build on top of it. But the general approach here, of course, would also work for other object-oriented programs that we want to create. It's not limited to games. So if you want to write some other kind of application, you can basically follow the same steps. All right, so that's it for exercise 43, and see you guys next time in the next video with exercise 44.